All right, let's get started with the review for Math 335. Reviewing 2.7, 2.8. I hope you guys watch the videos. It's out under the weather and we want to stay on schedule, so I just had to do that. So review of 2.7, which was graph translation or transmutations, I should say. Transformations, that's the right word for it. And then 2.8 was on functions, arithmetic of functions. So in 2.6, we went over the basic graphs. In 2.7, we were able to see how those graphs moved. So like if we had f of x or y equals x squared, this is x and this is y. The base graph has something where we go left to right 1 and up 1, left to right 2 and up 4. And that's our base y equals x squared. We saw that if we put a number in front of it, like let's say 1/2, what it does is it shrinks it, it makes it flatter. So everything only goes up half as high as it used to. So instead, when we go left to right 1, we go up 1, we don't go up 1, we only go up a half. And when we go left to right 2, we don't go up 4, we go up half of 4, which is 2. So this makes the parabola look flatter. And if we make it a negative x squared, what it does is it flips the graph upside down. But you still do the 1, 1, over 1, up 1, and then you flip it over the x-axis. Over 2, up 4, flip it over the x-axis means down 4. So if you know the basic movements of the basic graphs, everything's great. Doing like 1/2 x squared makes it shorter. Doing like 3/2 x squared, where it's bigger than 1, not less than 1, it makes it look like it's growing. Instead of going, when we go left to right 1, we don't go up 1, we go up 3/2, which is 1.5. And we go left to right 2, instead of going up 4, we go 3/2 times 4, which is 6. So we go up to the 6th point. And so what it's doing is it makes it look like it's stretching it or making it narrower. This is a little hard to do with my other graph there. So if we have ax squared, if a is greater than 1, it gets kind of narrower or stretches it like vertically, stretches it vertically. When a is less than 1, like here, but greater than 0, it kind of flattens it or makes it wider. And we can see down below what happens when it's negative. Negative a less than 0 does the same as a greater than 0, but it's flipped over the x-axis. I'm going to say flipped over its base axis. Because when we translate it, if we move this, it still shifts it from the new spot, not from here. In this case, x. This is true for any of the functions that we're looking at. You guys a chance to finish writing that down. All good? Wait, no, that's right. Good. So let's say we have, let's pick a different one, f of x equals absolute value x. That's always a good one. And we'll do our base graph in green. For the absolute value, it makes a V. And then if I do any translations to it, like let's take a look at f of x equals the absolute value of x minus 3 plus 1. What it does is this is like an x minus h and then a plus k up here. It shifts the center to hk, which is the opposite sign of the value inside. So this says negative 3, it's going to shift it to positive 3, comma 1 in this case. And my center is where the point is, which is called a cusp on absolute value. So I'm shifted over here, but then we still do the 1, 1 and the 2. We still do.
I have a question.
Yeah.
You said it was the opposite sign, so if it's plus 1, wouldn't it be negative 1?
On the inside one, on the outside one is the same sign.
Okay.
Good question. Sorry, I didn't make that clear. If my graph was better, this would look a little bit better, but still look like a B. Let's see. And if I were to add a negative to it, negative absolute value of x minus 3 plus 1. Well, if you want to see with the table, let's look at our starting point there. If I plug in 3, I still get 1. So it's still going to that point. If I do like -1 and then +1 each direction. If I stick in 1, I get 1 minus 3 is -2. Absolute value makes it +2. This makes it -2 again, makes it -1. If I stick in 2, I end up getting 0. If you go through them, you're going to get that, which shows even though the negative doesn't hit everything, just putting it on the outside of this thing makes the V go upside down. All from just this little negative sign right there. That flips the entire graph over. But it's easier to draw the graph translated and then flip it. Or you can do the tables here and just what the hell happened here? Yeah. Yeah, right. Okay. I confused myself. So you might find it handy to sketch the regular graph, translate it to HK. And then if negative, flip it over there. Or if you like doing the flip first, you can flip it first, then shift it. Yes. Mhm. Any questions so far?
Is this going to be on the test on Thursday?
Yes.
Okay, thank you.
That was a very sad sounding. You can see the practice midterm is up and there's only one graphing problem on there.
Yeah, I was going to say, I'm so excited. What are you talking about?
What?
I'm so excited for the test on Thursday.
Why? That's hella suspicious.
Because I love math.
Okay, good, awesome. I think I'm gonna feel like a trap. That's a trap here. Feels like a trap. If you want, I can make you some harder math problems for your test.
No, no.
Are you sure?
Yeah,
You'd really impress the shit out of me if you do the harder problems.
no, no. Yeah, no.
All right. Let's see if we do -2. Let's go +4. Let's let you guys try that for a second, then we'll do it together. Then we'll start looking at the arithmetic of functions. Thrown in full plate meal and didn't good still survive. This is no goals. Yeah, that's how I roll. Made it hard. All right, so for the base graph of x squared, we go left or right 1, up 1, left or right 2, up 4. This -2 is just a multiplier on that. It changes this up 1 and up 4 to times -2. Which means up -2 or down 2. And up -8 or down. So the x squared or the 2 doubles that it stretches it and the negative flips it. So we are going to be pointing downwards. Now you have a couple options at this point. Sketch that -2 or sketch this graph. I'm going to do this in light green and I'm not going to make it a solid line. I'm just going to graph it with dots. So 1 and -2 and 2 and -8, which is way the fuck down here. This isn't my official graph, so like if I had a pencil, I would do it in pencil, but I don't have a pencil. But those are the points I'm going off of. And then we can look at HK. H is -1 here. It's the opposite sign of what's on the inside. And K is +4. So we're going to shift the center to -1, 4, which is up here. So you have two options. Do this thing right here and then shift each one of these points -1 and up 4. Over 1, up 4. Over 1, up 4. So I took each of these points and I shifted it over and up 4. That might be, that's one way to do it. The graph is definitely here. So here I drew it and then translated. You might like better just figuring out where the center is, find the center. Like we did up here, the -1, 4. B, figure out the movements and go from there. So what I mean by that is I start at -1, 4, and I pretend I haven't looked at that green graph. From the -1, 4, I do this over 1, down 2. So I go right, left or right 1, down 2. And then I go left or right 2, down 8. So I can find the points from there and connect from there, or you can draw what the graph looks like and then move it, whichever one you're like comfortable with. They both end up, the points still end up at the same spot. Some people like sketching it and then moving it, and some people just like moving it and then drawing from there. I am more of the latter one. But I've had students tell me that's just like, can't, no, not doing it that way, can't follow it. I am very much move the center and draw the graph from there. But you can do it however way you wish. As long as you get the help, you can do X and Y. You can make a table and plot points. You're going to slow yourself down. It's a lot slower if you learn how the basic graphs shift and stuff like that. It makes it a lot easier to read graphs and shit from then on, if you master this stuff. You guys ready for more? All right.
Yep.
Scared the shit out of me. All right, let's take a look at arithmetic and functions. This was 2.8. We have two functions, f of x and g of x. F plus g of x like that means f of x plus g of x. If I throw in a minus sign, it means subtract them. F g of x like that means f of x times g of x. And it's probably helpful if you put them in parentheses when you do that. That way you recognize that you might have to do some distributing. F over g of x like that is, of course, division. And those are all relatively straightforward. The one that gets students the most is the log of x and golf of x. This is f of g of x. So you put in g of x inside of f of x. And on this one, we put f of x inside of g of x. So these two are the same, and those two are the same. So maybe doing fog x, let's say f of x equals 3x squared plus 5x plus 1. And g of x equals 2x minus 1. F of g of x, or fog x, I am going to stick g of x inside of f of x, which means I am replacing in the f function, everywhere it says x, I'm going to put in 2x minus 1. That's my g of x. So you might find it easier to have parentheses in. And then make that substitution. You probably want to distribute and clean this up. And if I square that, I'm going to get 4x squared minus 4x plus 4 on the inside. Remember, this part right here is 2x minus 1 times 2x minus 1. So you have to distribute. You can't just square each thing individually. That's an aside. Then I have this part. I won't distribute yet. I'll just deal with the square first. We distribute on the next line. I distribute the 3, I've got 12x squared minus 12x plus 12. And then I do this part, I've got plus 10x minus 5. And then I've got plus 1. And finally, I would clean it up by combining like terms. F of g of x is 12x squared. I have a negative 12x and a plus 10x is minus 2x. And I have a 12 minus a 5 is 7 plus 1 is 8. Ready for more? Something that does a little bit of the arithmetic stuff, and we're going to do it again after the practice because it is on the exam doing the difference quotient. The difference quotient, you're not expected to memorize it, I will show it to you on the test, is doing f of x plus h minus f of x and then divided by h. When you get to calculus, in calculus 1, this is the definition of the derivative. But it's all calculated doing some basic function work. So let's do that with the f of x I had. I had 3x squared plus 5x plus 1. You might find it handier to do them separate. Figure out what each thing is on its own and then put them all together into this big thing. So if I do f of x plus h, I have 3 times x plus h squared plus 5 times x plus h plus 1. Let's see, and then we have, if I do that as a square, remember this is x plus h times x plus h. If I multiply that out, I get x squared plus 2hx plus h squared. And I still have the next thing, which is 5 and then x plus h plus 1. So all I did is deal with the square right here. I will distribute. And nothing really cleans up. That is f of x plus h. Nothing combines. Then we take a look, we already have f of x. So now let's put it all together. I've got f of x plus h minus f of x divided by h equals 3x squared plus 6hx plus 3h squared plus 5x plus 5h plus 1. And then I'm doing minus f of x. Which means I'm going to hit each of these with a minus line. So minus f of x, maybe I can put it in parentheses for now. Just so we make sure everyone gets where it's coming from. Divided by h. So if I write above it, this actually, when I distribute, I got negative 3x squared minus 5x minus 1. So my 3x squareds cancel out. My 5x's cancel out. And my 1 and negative 1 cancel out. What I'm left with is 6hx plus 3h squared plus 5h over h. You can factor out an h out of each of those. On top. And so that when we cancel, you can see that f of x plus h minus f of x for h is just 6x plus 3h plus 5.
And so that is called the derivative?
Well, it's part of the derivative. The derivative actually has it where we do, it's called the limit as h approaches 0. So we send h to 0 here. You can't do divide by 0 over here, but once you're over here, the limit as h approaches 0 of this f of x plus h minus f of x over h. You can evaluate at this point, we can evaluate the h at 0, treat it as 0. And so the first, or the derivative would be 6x plus 5. In terms of just doing the difference quotient though, the difference quotient is that part. Difference means subtraction and quotient is division. So that the name kind of tells you what's in it. So you learned some calculus today. You're not being tested on calculus. Just being able to manipulate functions. When you do calculus, you'll start with this. You'll apply it to a whole bunch of different types of things. You'll figure out what the shortcuts are, and then you won't have to do this ever again. There are a lot of shortcuts where you can start here and go straight to here. But they all stem from being able to do this. Only a couple minutes left till 3. I guess we'll see if there's any questions. Otherwise, we'll chill for a few minutes till everybody else gets here. Do the practice exam. Do we have any questions from our home viewing audience?
No.
So we do it so the actual midterm is Thursday.
Yes, you'll have to be here in person.
I will do that.
I didn't mean to stop sharing.